All right, so let's get going on today's class. So today we're going to continue our look. Today we're going to continue our look at confidence intervals. So this was the idea that we introduced last class, where we were taking a look at the kind of next step that you would take after doing a hypothesis test, especially if you're doing psychology in an applied setting. So up until now, we've been doing hypothesis tests. We will return to that next week or in this coming lectures for the ANOVA. But right now, we wanted to finish off our look at t-tests by taking a look at confidence intervals. So once again, this is a way of not just detecting if there's a difference, which is what the hypothesis tests were all about, rejecting or accepting the null hypothesis. This is a way of actually estimating quantities. So this is oftentimes used in applied settings. So we saw the example with the monkey sanctuary, where if this monkey sanctuary was required to quarantine its infant monkeys, but wanted to make sure that they could provide them with comfort with a terry cloth mother, but did not have enough money to buy every single monkey a terry cloth mother. They had budget restrictions. They would want to know not just that your monkeys or that monkeys prefer the terry cloth mother, which was enough for Harlow as a psychologist. They would want to know, how long do these monkeys spend with a terry cloth mother? How many would they need to buy? You know, if they spend 15 hours a day, do they spend 18 hours a day? And they would also want to have a certain level of confidence in that estimate to know exactly how likely it is that your estimate is correct. And today we're going to extend that example and extend confidence intervals to take a look at the Loftus and Palmer study on the difference in eyewitness memory between different questions. How fast was the car going when it hit the bus? How fast was the car going when it smashed into the bus? And again, for a psychologist, it's just enough to know that there is a difference. That kind of opened up an entire new avenue of memory research, that there was a difference in speed estimates. But in the real world, if you're dealing with, for example, a court case, it then becomes an important question of how big is that difference. We need a psychologist to estimate not just that there is a difference, but estimate how big of a difference there is. So if this was the question that was asked in a court case and the eyewitness reported 60 miles an hour as her estimate, if she was misled by the question, by how much did she overestimate that? You might be called in as a psychologist to say, well, she overestimated it by 10 miles an hour. Or was it 15 miles an hour? How many miles an hour did she overestimate her eyewitness testimony? And then the last example we're going to take a look at is from organizational psychology. So if you're an industrial organizational psychologist, you might get called in by a business to analyze their business practices. So say they put their workers on a timeout schedule, where if their workers make an error during their work, they're actually put on a timeout where they cannot earn their salary. They might want to know, what kind of increases in accuracy can we expect? Because they got to do that calculation that says, does the increase in accuracy offset the loss of work during the timeout period? They're going to need to crunch those numbers. So they don't care that the subjects were better in the 10-second versus 5-second condition. They want to know how much better. Do we actually go with the 10-second condition because it's so much better than the 5-second condition, or is that trade-off not monetarily feasible? So they need to know what is the increase in accuracy they can expect. So this is going to be, as we go through this is going to be a little bit of a Wizard of Oz moment here, because what you're going to find is kind of like what Dorothy found at the end of the Wizard of Oz. So it turns out that you have been calculating confidence intervals this entire time. So this entire time that you've been doing t-tests, you've been calculating confidence intervals. So you're going to have a little bit of a Dorothy experience here. So just bear with me. It's easier to teach t-tests and then go back and do confidence intervals. So don't get angry at the good witch. All right. Mm-hmm.
Maybe if you just try to restart it.
Can you refresh it? Just a little circle thing. Oh. No, that's not refresh. Well, that'll do it. Yeah, close it, see if you can get back to this. Yeah. Not sure what's going on there. All right, so today we're gonna have a quick overview of confidence intervals. Then we're gonna round out our look at confidence intervals, see how to do the final 2 confidence intervals in SPSS, and then we'll turn it over to in-class practice, and I'll just mention the homework assignment that's coming up. All right, so once again, quick overview of confidence intervals. So confidence intervals consist of 2 parts. They consist of the point estimate, and they consist of the range around the point estimate. And that range is what gives us the confidence that we the confidence number that we can assign. So that range is what gives us 90% confidence, 95% confidence. And the way that it does that is that we make the range as wide as the body of this comparison distribution. So we decide what percent to put in the tails and how wide the body is for the distribution. So if we put 5% in the tails, what that means is that we got 95% in the body, right? So that is the logic behind how wide the body is. And as you can see, when we take a sample that we build our confidence interval around, when we take a sample mean, right, these M's here, when we take that sample mean and we build that confidence interval around the sample, we only have the one sample. And we don't know from where in this comparison distribution it comes from. We don't know where our sample is in that comparison distribution. But what we do know is that if we make our interval as wide as the body of the distribution, the only time the interval is going to miss estimating correctly the population mean, the only time the interval is going to miss estimating correctly what we're being asked for is if we got unlucky enough to end up with a sample that came from the tails. And we know the probability of ending up with a sample that came from the tails because we made the tails, and in this case we made them 5% of the distribution. So the only way we miss is if they come from the tails, if our sample came from the tails, then we have a 5% chance of missing our estimate. What that means is that we got a 95% chance of getting it correct, which means we can be 95% confident in our confidence interval. And we can shrink and grow those tails as much as we can, or as much as we want. So if we want to be 99% confident, we got to put 99% of the distribution in the body, and that means that we only have 1% in the tails, a 1% chance that our sample came from the tails and we missed the estimate, 99% chance that it came from the body, and we hit that estimate correctly. All right, and then the formula for this, what it's all based on, is it's based on that t-test formula. So that t-statistic that we were calculating over and over and over again before we turned it over to SPSS, that sample mean minus your population mean divided by your estimated standard error, notice that it has what we want to estimate. We want to estimate that population mean. We want to estimate, for example, how long do these monkeys, the population of monkeys spend with the terracotta mother. So all we did was take that formula that we've been working with for a while now, and we isolated for population mean. So we did a little cross multiplication. We brought population mean over to the other side, changed the sign. We brought t times the estimated standard error to the other side, changed the sign. And then because the t-statistic is 2 tails, it's plus or minus, we just change that to plus or minus. And then that is the formula for the population mean estimate. It's your sample mean, that's always your best guess, plus or minus a certain range. And that range is determined by your t-statistic, which determines how big your tails are, multiplied by your estimated standard error. And as we saw, that breaks down to this. So your population mean, what you're trying to estimate equals your sample mean. That's your point estimate. That's your best guess. Plus or minus your t-statistic multiplied by your estimated standard error. That is what determines the size of one of your arms. So plus goes the positive way, minus goes the negative way. That gives you the full range for your confidence interval. All right, so that's an overview of the basic idea of the confidence interval. What we're going to do right now is we're going to put it into practice by calculating 6 more confidence intervals for 2 different situations. So we've already looked at Harlow. We've already looked at the monkeys with the monkey sanctuary. And we're now going to switch to Loftus and Palmer and basically take a look at how to calculate not just that they overestimated their estimates of speed, but by how much did they increase that estimate of speed. And again, this might be used in a court of law where a witness was asked an unfair question. The prosecution was leading the witness. You'll hear that a lot of times in law drama TV shows. Hopefully you won't hear it in court too often. But again, once that question is asked, you can't unring that bell. You can't say, just ask as if the question, act as if the question wasn't asked, because that memory's been rewritten. So what a court might do is they might call you as an expert witness and say, look, this person said the car was going 66 miles an hour. If it's 66 miles an hour, guess what? That's criminal negligence. That's manslaughter. If it's not 66 miles an hour, then it's an accident and it's a lesser charge. So principal's lives hang in the balance. What are you as a psychologist going to do? Well, you're going to calculate a confidence interval. So we go back to the independent means t-test because that is the situation that this calls for. So once again, the confidence intervals come straight out of the t-test. So I'll reread the situation. In 1974, Loftus and Palmer conducted a classic study demonstrating how language used to ask a question can influence eyewitness memory. In the study, college students watched a film of an automobile accident and then were asked questions about what they saw. One group was asked about how fast were the cars going when they smashed into each other. Another group was asked the same question, except the verb was changed to hit instead of smashed into. The smashed into group reported significantly higher estimates of speed than the hit group. Suppose a researcher repeats this study with those scores right there. So for the t-test, all we asked was, do the results indicate a significantly higher mean for the smashed into group? And we saw that it did. We saw that they actually did have a significantly higher mean. Now, after that significant effect, we might ask ourselves, well, how much faster were the estimates for the smashed into group? What was the difference between the hit group and the smashed into group? How much was that overestimation? So that's when we need a confidence interval, and we're going to compute a 95% confidence interval. We're going to compute an 80% confidence interval, and then we're going to round it out with a 99% confidence interval. All right, so for this, what we're going to do is we're going to set this up in SPSS as usual. There are the screen grabs of what we're doing. But again, this is something that we've done before. We are setting up an independent means t-test. So we're going to be using this data right here. All right, so this is the data. This is the raw scores for the t-test. But just because we want to make sure that we got enough practice time, this is going to be like one of those cooking shows. Here's that SPSS data that I've already prepared. So right below it, it is formatted for SPSS. So you can grab that speed and group. It's all set up. Whoops. So it's all set up for you. So you can, I hate those little pop-up things. There we go. So you can copy it, paste it into SPSS, and basically get to the point where you are just about ready to run your independent means t-test. All right, so you pop those in. All right, and then in our variable names, we got speed. And then in the string name, we got group. And we go to, once we have this set up, so that is set up for the independent means t-test. Once we got that set up, we go to analyze. We go to compare means. We go to independent samples t-test. So the first thing you need to do when you're doing a confidence interval question is you need to identify the t-test that the situation calls for. So in this situation, we have two separate groups of subjects, each of them measured once. That's an independent means t-test. That's why we're doing an independent means t-test. Once you know that, you run it as if it's an independent means t-test. You have speed as the testing variable. You have group as the grouping variable. We define the groups. Group number 1 is smashed. Group number 2 is hit. We hit continue. And if we were doing a t-test like we've done before, this is where we would just hit OK. It would run the t-test. However, we are now doing a confidence interval. So that's when we go to this little options button here. And we click on that options button, and you'll see that very nicely. The first thing that it says is confidence interval percentage. So that's where we enter in our confidence interval percentage. So the first one that we wanted was 95%. That is your default. That's the one that it's set up for. So we hit continue. We hit OK. And we have SPSS running our 95% confidence interval. And again, very nicely, SPSS right here on the last two columns identifies the confidence interval that you have run. That is very helpful when you're running multiple confidence intervals, just in case you forget what was the percentage that you used. So if we go back to the question, notice that it asked us for a 95% confidence interval. We have done that. Next one that it wants is an 80%. I see a question. Okay, so let me see your input. All right, let me see your test. So analyze.
This one, right?
Yep. Okay, so that has to be case sensitive. So it's got to be capital S, capital H. That's why it's finding nothing, because it can't identify the groups.
Okay.
Yep. All right, so we need to do another test. We need to do an 80% confidence interval. So we can go back to our data set and once again analyze, compare means, independent samples t-test. Once again, we go to options. This time we're going to set that to 80. So an 80% confidence interval. We hit continue. We hit OK. And it has calculated out the 80% confidence interval of the difference. And then finally, we want to do a 99% confidence interval. So once again, we go to analyze, compare means, independent samples t-test, go back to options. This time we switch it to 99. And notice it remembers the last confidence interval that you've done. So be sure to go in there, change that to 99, hit continue, hit OK. And we have calculated our three confidence intervals, the 95, 80%, and 99% confidence interval.
Do we need to request the little options to click underneath, like exclude, stuff exclude?
Nope. Those are grad school options. Those are like later on. All right, so we've calculated out our confidence intervals. So now what we need to do is we need to analyze them so that we can figure out where to look for the information that we need. And the thing about SPSS is that it gives you a range for your confidence interval. So it'll give you basically a confidence interval that looks like that. And what you need to convert it to is a confidence interval that equals your sample mean plus or minus that t-statistic multiplied by your estimated standard error. And thankfully, SPSS gives you enough information to calculate this, but this is the form you want to have it in because this is the form that most people accept. It's that classic, here's our best guess, plus or minus this much. And if you ever hear confidence intervals reported on the news, and they're going to be reported a lot in the next coming time as the elections start to go into full swing, you'll hear polls all the time saying things like, well, support for, this candidate has 20% plus or minus 3%, right? That's that plus or minus 3%. That's what we want to figure out. So we want to make sure that when we're doing this, especially since it's more of an applied skill, we want to make sure that we put it in a way that somebody who isn't in this course will understand. So we got to take it from what SPSS gives us and put it into that format right there. All right, so how do we do this? We need to find that information. So it looks like we're going to start with that 80%, nope, 99% confidence interval. And very nicely, SPSS identifies this as a 99% confidence interval of the difference. And this is important because that's exactly what we wanted. We weren't asked how fast or what speed did the smashed into group estimate. We were asked how much faster. So again, this is an example where we're looking for the difference in this case. So it gives you that confidence interval of the difference. Make sure you note that when you're answering your questions. Are they asking for the absolute amount? Or, as in this case, are they asking for the difference? All right, so once again, we're going to camp out on this first row right there. So we got equal variance as assumed. Our degrees of freedom, if we wanted to look up this T statistic, we would need our alpha level, which in this case would be 1% because it's a 99% confidence interval. We got 1% in the tails. We would need our degrees of freedom, which in this case is 23. We could then go to the T statistic table and look all that up. That's kind of a long way to do it. We're going to take advantage of what SPSS gives us, however, and take a shorter route. So that information, the degrees of freedom, allows you to look up your T statistic. That's your estimated standard error. That would be this part right here. So you could use that to look up this information. But as we're going to see, SPSS has already calculated this out for you and has calculated it in that 99% confidence interval of the difference. So that gives you the information that you need. That's where we're going to camp out here. So the first thing that we need is just to back up a bit, the first thing we need is that mean difference. That mean difference is your best guess for the difference, right? So again, remember, we were asked how much faster were the estimates of speed? What was the increase in the estimates of speed? And that mean difference is that increase. So the mean difference is 6.8 miles an hour. And if we could only give one answer, that would be our answer. We would say, this person, this witness, overestimated their speed by 6.8 miles an hour. And that mean difference is actually straightforwardly from the mean for the smashed into group minus the mean for the hit group. So you see up here, the mean for the smashed into group is 40.8. The mean for the hit group is 34. That difference is 6.8. That's where that value comes from. So that's the best guess. That is, we don't need confidence intervals for that. That's your point estimate. How do we figure out our confidence intervals? Well, for that, we go to our lower and upper bounds. And the lower and upper bounds tell us what is the maximum point of our confidence interval. In this case, it's 14.06 miles per hour. That is the most we're willing to estimate that the speed was overestimated. And then the least is actually minus 0.46 miles an hour. So we actually are saying maybe they underestimated the miles per hour. So they could have, our best guess is 6.8 miles an hour over. Our maximum guess is 14.06 miles per hour over. And our minimum guess is they actually underestimated their report by 0.46 miles per hour. So this is all from SPSS. But what we need to do now is we need to change this, what SPSS gave us, into this format over here. So for that, we need to use a little bit of logic, we need to use a little bit of math, and we're going to use those numbers. But what we do is, first thing, we realize and we remember, and this is going to be the center of your interval, your mean difference is the center of your interval. So this mean here is your sample mean difference when you're being asked for the difference. So that is that 6.8 miles per hour. Okay, so One thing to remember is that for all your confidence intervals, for a particular situation, it doesn't matter if it's a 99% confidence interval, 80% confidence interval, 50% confidence interval, it doesn't matter how wide your interval is, the center of it is always going to be the same. The center of it is always going to be your best guess. The center of it in this case is always going to be 6.8. Then what we need to do is we need to use that information to get this plus or minus. And what that plus or minus is, it's basically the length of that arm. So it's the length of your arms. That's what that plus or minus is. And one way to do this, and I would highly recommend if you're kind of struggling with this, memorize one way. One way to do it is to take your upper value, 14.06, and subtract your center value, 6.8, and that is the length of your arm. So 14.06, 6.8, what do we do, 7.26? Seems right? All right, so that is going to be the length of your arm. So this is going to turn into 6.8 plus or minus 7.26. Oops. And that's how you get it into the form that is, most people will understand. That's how you get it into that mean plus or minus form. So remember that. Center of your distribution is that mean difference. That is the mean. Again, mean difference. There's your mean right there. The plus or minus is the length of your arm. Easiest way to get that, you take your upper bound minus your center point minus your middle. That'll give you a value. That is your plus or minus. This is literally your t-statistic multiplied by your estimated standard error, but you can use SPSS as a shortcut to get there. And in this case, we got plus or minus 7.26. All right. So we computed our intervals. So now, what does this mean? So this was for the 99% interval. So let's start off with just the point estimate. So let's say that you are on the stand and you're being asked by the defense attorney. And the defense attorney said, all right, how much did that previous witness overestimate their speed estimates? You know, give me an estimate of how much they overestimated their recollection. And if they were asking for an estimate, your best guess would be your point estimate. You would say, well, you know, the science and my knowledge and the research that's been done has shown that the estimate, the overestimate, was 6.8 miles an hour. That's my best guess. If they then ask you, are you confident in that estimate? You would say, no, not at all. That is a point estimate. I can't be confident in a point estimate. It's got high precision. It's got low confidence like we saw last time. So then your attorney might say, well, what are you 80%? Give me an 80% confidence interval. And you would say, all right, I'm going to give you a 95% one instead. If they say, give me a 95% confidence interval, you might say, all right, it's going to be 6.8 plus or minus 5.35. So notice in this case, your entire confidence interval is in the overestimation side, right? So this is no difference between the estimate, between the eyewitness testimony when they were asked correctly or incorrectly. This side over here is overestimation. This side over here is underestimation. So what this confidence interval means is that if the judge asks you, are you 95% confident that this witness overestimated their testimony, you can be like, yeah, I am 95% confident that they overestimated their testimony. They overestimated it 6.8 plus or minus 5.35. So that is the width of that particular overestimation. If the prosecutor then said, whoa, wait a second. What about an 80% confident interval? We don't need to be 95% confident. We just need to be 80% confident. You would say, all right, 80% confident, still 6.8. All right, notice the center of your confidence interval has not changed. But now it's going to be plus or minus 3.41. Because if you're less confident, you can shrink down that confidence interval. The confidence comes from the size of the range. So if you're less confident, your confidence interval shrinks down. So that would be an 80% confidence interval. And then finally, the judge might step in and might say, look, in order for this to be legally admissible in a court of law, you got to be 99% confident, right? That's the burden of how confident you need to be. What's your 99% confidence interval for the overestimation of speed? And if you said, all right, 99% confidence interval, that is going to be 6.8 plus or minus 7.26. And notice that this interval here includes the no difference between the estimates. So this includes the fact that the question might not have changed or overestimated the witness's testimony. So you can be, what this all means is that you can be 95% confident that this witness has overestimated their memory of the event. They've overestimated the speed that they remember. You can be 80% confident that they overestimated the speed that they remembered. However, you cannot be 99% confident that they overestimated the speed that they remembered, because your 99% confidence interval contains no difference. It contains the possibility that they underestimated. And we can see that here with this negative value right there. So again, if the judge asked you in this situation, are you 99% confident that the witness overestimated their testimony? You as an expert witness would have to say, no, I'm not 99% confident, because that 99% confidence interval contains 0, which is they got it exactly correct, and it also contains this little section over here, which actually says that they underestimated. Right? So that's how a confidence interval can give you insight in terms of whether or not you can be confident enough to say yes or no to certain questions. Yep.
So when we plug in the value that's like half of the possible amount, then we're going to get just plus or minus, right? Not both.
Say that again.
Okay, so when we do the confidence interval thing, we're putting in for when we plug in the amount, the test value amount. So if we put the half of the possible value in, then we wouldn't have the plus or minus, right? We would have a plus or minus for the mean plus the.
I think, are you talking about the test value for one sample?
Mm-hmm. Oh, I'm sorry.
T-test?
There way. We're doing
Yeah. So that's for the different t-tests. And as you see, the calculation of the t-test, because it depends upon your comparison distribution, you need to choose the correct t-test when you're doing that particular confidence interval. No problem. All right, so that is the independent means t-test. Now we're going to wrap up our look at confidence intervals with the dependent means t-test. So once again, we took a look at that study that indicated that timeout is effective in adults. We found out that people were more accurate in the 10-second timeout condition than the 5-second timeout condition. But again, if you were going to implement this in a place of business, you would need to know how much more accurate was the 10-second condition compared to the 5-second condition, because you would have to crunch those numbers to see if the trade-off in accuracy makes up for the loss in time that your workers are working, basically to protect your bottom line. All right, so once again, we had the situation where our data comes from for analysis. So this is also important. You need data to base this on. You can't just say, well, as a psychologist, I got a feeling about this or this. You got to base it on some data. So we go to the data from our experiment. And once again, you have to identify which t-test is being done or needs to be done in order to calculate the confidence interval. So once again, here we have 9 participants. They completed the 5-second timeout condition, and they also completed the 10-second timeout condition. One group of subjects measured twice. That's a dependent means t-test. So when we're asked how much more accurate were participants in the 10-second timeout condition, we know that we need to do a dependent means t-test to calculate those confidence intervals. And once again, we'll do a 95, 80, and 99% confidence interval. So once again, it's going to be the exact same kind of setup. So let me just erase the actual numbers that we calculated for the last one. and we'll see how SPSS can help us calculate these new confidence intervals with a dependent means t-test. All right, so once again, note we're doing a dependent means t-test. Once again, note we are asking for a difference in this case. How much more accurate? Now how accurate were the subjects in the 10-second condition, but how much more accurate were they? So again, we're looking for a confidence interval of the difference. All right, so we're going to go back to SPSS. So once again, set this up as if you're doing a dependent means t-test. And again, we go back to our data here. This is demo question number 3. So this is again set up in order or the way that SPSS wants it. So let me just close this. Clear these out. All right, so set it up for a dependent means t-test. Nope. All right, so once again, we have your 5-second condition, but we can't call that 5 seconds. We got to call it second 5. We got our 10-second condition. We can't call that 10 seconds. We got to call that second 10 because SPSS will not let you do that. And then we go to, once we got that set up, we go to analyze, we go to compare means, and we go to the section, the selection for the dependent means t-test, which again in SPSS is called the paired samples t-test. We click on that, and then this is going to be one of those cases where you're going to want to make sure that you're getting this done the correct way. And this is what I mean by this. So we all know we take our variable, one of our variables, we pop it into variable 1. We take the second variable, we pop it into variable 2. That's set up for the t-test. We got to hit that options button. And again, that's where your confidence interval percentages are found. So the first confidence interval we want to do is 95%. It is already set up. That is the default. So we can just hit continue. We hit OK. And we calculate our 95% confidence interval. Now, notice, right off the bat here, we have a mean difference of 7%. More importantly, we have a mean difference of minus 7%. We are being asked how much more accurate is the 10-second condition. And what we have done is because we went the 5-second condition minus the 10-second condition, if the 10-second condition is more accurate, then that difference is going to be negative. So we have now painted ourselves into a corner where increases in accuracy are going to be shown by negative numbers. So we got two options. We can either sit here and say, all right, this indicates that the 10-second timeout condition had a decrease in accuracy of minus 7%, which is an increase in accuracy of 7%. We can either do that, or we can say, whoa, 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 let's get rid of this. Don't save that output. Let's go to analyze. We'll go to compare means. We'll go to paired samples t-test. We put these in the wrong way. So let's go back here, and we're going to use this little arrow button here. We're going to switch them. We're going to flip them around. So that 10 seconds is in variable 1 right now. We go to options, 95% confidence interval. That's what we want. Continue, OK. And now look, we have our increase in accuracy for the 10-second condition being shown by a positive number. It's just going to make life a whole lot easier down the road. All right, so that was the 95% confidence interval. Feel free to work ahead. We got to go back to analyze, compare means, paired samples t-test. Once again, we got to set up correctly now. We can just go to options. We want an 80% confidence interval. Hit continue. Change your confidence interval percentage to 80. Hit continue. Hit OK. SPSS calculates an 80% confidence interval of the difference. Once again, very nicely labels it for you right there. And then finally, we need that 99% confidence interval, analyze, compare means, paired samples t-test. We go to options. We want that 99% confidence interval. We hit continue. We hit OK. And we got our 99% confidence interval as well. All right. So now that we got those outputs, now it's time to once again kind of figure out what it is that we have. So we'll take a look again at a zoomed in version here. So this is for the 95% confidence interval. And notice I got this backwards in the lecture notes. It doesn't matter. I'll do the mental gymnastics. You follow along with your own output. But once again, SPSS has given us the output that we need. If we need to figure out the estimated standard error portion of this specifically, that is our estimated standard error right there. If we need to figure out the t statistic specifically, there's your degrees of freedom, so you can look it up in your t distribution table. However, SPSS has done those calculations for us, so we just need to know where to look. And where we look is in that 95% confidence interval of the difference. And that's where we're going to get this information here. All right, so let's start piecing together our confidence interval. The first piece we need is our mean, right? The mean difference is going to be our point estimate. And in this case, because I didn't switch it in the notes, it's -7. But that means that for your notes, it's going to be 7. So the increase we can expect, our best guess, is we can expect a 7% increase in the 10-second condition. And again, that just comes from the fact that the 10-second condition has 83.1 accuracy, 5-second condition has 76.1 accuracy. The difference between those two, 7%. So that's our best guess right there. We then go to the upper and lower values. Now again, I didn't do the flip-a-roo in the lecture notes, so just bear with me here. If we remove the negative signs for those, you will see that your upper value is 11.61. You will notice that your lower value is 2.3, I'm going to round it, 3.9. That's what your upper value and that's what your lower value is. I'm doing the mental gymnastics because I forgot to flip it in my notes. Take advantage of not having to do that. And when you're reading your SPSS, flip it if you need to in order to get the correct information. All right, so now we have our upper bound, we have our center, and we have our lower bound. But we do want to get it into this mean plus or minus some value. So for that, we need to use some logic and some math. So the first thing that we do is we have our center of our confidence interval. That is your mean difference. In this case, it's 7%. And then we need our plus or minus portion of it. And that is going to be always, always, always your upper value minus your middle value. So we go upper minus middle. We go 11.61 minus 7.0. That gives us a difference of 4.61, and that is our plus or minus 4.61%. And notice that that would even work with these numbers here. So if you take minus 2.38799 and you subtract from that minus 7, you're going to end up with positive 4.61. So it's foolproof. It'll always work out. Go upper minus middle, and you'll find the length of your arms. All right, so once again, we have, what does this all mean? So right here is no difference. Right here is the line where up here, 10-second condition is better. Down here, 10-second condition is worse. There's a line that there's no difference between the 10-second and 5-second conditions. And if we were called into this meeting, and somebody said, well, you're a psychologist, you've analyzed, this type of research. what's the increase in accuracy we can expect? We're thinking of moving our employees into either a 5-second or 10-second condition. How much more accurate are they going to be in that 10-second condition? Well, you would say my best guess, my point estimate is 7%. You can expect a 7% increase in accuracy in the 10-second timeout condition. And if they ask you, are you confident about that estimate of 7%? You would say, not at all. That's a point estimate. It's highly precise. It's got no confidence whatsoever. So then if one of the board of directors says, you know what, before I invest my money, before I put this company at risk, I need to be 95% sure that the 10-second condition is better. And you can say, all right, 95%? Absolutely. That is going to be 7% plus or minus 4.61. So you can expect a 7% increase, maybe all the way up to 11.61%, but definitely at least 2.39%, right? I am 95% confident that you can get at least 2.39% increase. If another person on the board of directors says, well, you know what? I'm kind of cavalier. I like to take risks. I don't need to be 95% confident. I only need to be 80% confident. What kind of increases are we talking about? You can say, all right, 80% confident. We're still looking at 7%. That's always going to be the center of your confidence interval. But now we're looking at 2.79, plus or minus 2.79%. So you can expect accuracy increases all the way up to 9.79%, or at the very least, you can expect 4.29% increase in accuracy. That's what you can expect. And he might be sitting there going, wow, minimum 4.29, we should definitely do this. Let's go ahead. And then you got the last board of director, person on the board of directors. And they say, you know what, I got to be 99% confident. I borrowed money from the wrong people. They're going to come after me if this doesn't work out. I can't risk it like these other guys. I need to be 99% sure. And you can say, all right, there's your 99% confidence interval. So I am 99% sure that you're going to expect accuracy gains of 7%, maybe all the way up to 13.71%, maybe that high, but at least it's going to be 0.29% of an increase. You can expect, I'm 99% sure that it's going to increase by the very least 0.29%, and that's your 99% confidence interval. So again, notice, lower confidence, smaller interval, higher confidence, larger interval, and that is again determined by your body of your comparison distribution. Yep? Okay. All right, so, whoa, due December 3rd. See you next year. All right, so I got to double check when that's due, but let me just mention right now, so now you are ready. That's not the due date. Check Canvas, check your syllabus for when the actual due date is. But you are now ready to complete the homework assignment. So previously, we only had the single sample t-test confidence intervals that you can do. Now you can do the final two. So in your homework, once again, identify which confidence interval is being asked for, which t-test you need to run, and then complete your analysis. Find your center, find your top minus your middle, and pay attention whether it's asking for an absolute amount, how much of this, or if it's asking for a change, how much of an increase, how much of a decrease, and answer that accordingly. Remember as well that this assignment is self-grading, so you can try it as many times as you want. The grading formulas will continually update, so it's much like a homework assignment where you got multiple attempts. Feel free to try it as often as you like. And what we're going to do now for the remainder of today's class, there are two more problems that you have that are demo problems that you can practice your confidence interval skills. Here are the descriptions. So we got demo question number 4 and demo question number 5. Use that information to identify what kind of a test needs to be done. And then there are the answers for those. So again, see if you can get your demo questions into those forms. You also have your homework to work on. So feel free to do that during the practice session. If you're all statsed out, feel free to call it an early day. If you need assistance, call me over and I'll be happy to help. Other than that, we are done for what I wanted to cover today.